In this video, we're going to go through the process of writing your own class. So when you write your own class, there are a couple of components that you should always include, and those are the instance data variables, constructors, getters and setters, and a toString. Now there's going to be more that you'll add to your own classes, but those are kind of the basic building blocks that should always be there. So when we first write our class, we want to think about what instance data variables should go in that class. And instance data variables are how we represent the characteristics or the descriptive pieces that describe our objects. So in this example, we're going to write a class to describe a student. You can think about this class being used in some sort of system at a college, for example. And you can think about a lot of things that would describe a student: their name, their address, their course list, whether they paid their tuition, their GPA, lots of things. We're going to keep it very simple for this example, and we're just going to describe a student by their first name, their last name, and a numeric student ID. So again, obviously this is a very simplistic example. You can think of a lot more things that we could use to describe a student. So when we first think about a class, we think about how we want to describe objects of that class. And once we know that, then we think about what type those should be. So I'm going to make my first name and last name strings, and I've said that I'm going to make my student ID be a number. You could think about, obviously, a student ID having some letters in it, but for this example, I'm just going to make it numeric. So when I write my instance data variables, I always make them private, and that's to preserve encapsulation. So encapsulation is an idea within object-oriented programming that each class should manage its own information. So the student class should be solely in charge of managing the information that describes a student. So that means we make it private to other classes. Now, other classes can access that information through public methods that we provide in the student class, but we don't give direct access to these variables. And that's a very important design aspect about object-oriented languages in general, and Java in particular, is to keep and maintain that encapsulation. So you always want to have your instance data variables be private. So I'm going to have private string first name and last name and private int student ID. So that's the first piece I think about, is the instance data variables. Then next I write my constructor. The job of the constructor is to set up objects from the class. So for my constructor, I need to think about what kind of information do you have to give me in order for me to be able to set up a student object. Well, in this case, you kind of have to give me all three pieces of information, right? There's no real default values I can use for a student's first name, last name, or student ID. So you need to give me all the information. So you need to pass in the first name, oops, which is a string, the last name, and the student ID. And when you do that, I then use those information, those values rather, to assign values to my instance data variables. So I say the first name associated with the current object gets the name you passed me. The last name associated with the current object gets the value you sent in as a parameter. And same thing, the student ID associated with my current object gets the value passed in as a parameter. This is one of the uses of the this keyword, is to differentiate between variable names and parameter names that have the same name. So if I have an instance variable name, first name, and a parameter, first name, this dot first name refers to the instance data variable version because this means the current object. So I'm saying the first name of this current object that I'm creating in my constructor. And without the this, it's just the parameter. So I'm saying the object's copy of first name gets the value you pass me as a parameter. So now I've got my instance data variables, those describe my object. I've got my constructor, which sets up instances of my object. Next up is my getters and setters. So getters are pretty straightforward. They are public methods that return a value of an instance data variable. So I'm going to have public string get first name, and all it's going to do is return the value of first name. And I'm usually going to have a getter for each instance data variable. There's some cases where you might choose not to have a getter, but for the most part, you will have a getter for each instance data variable. And for the most part, your getters are going to look pretty similar to this. They're just public with the return type that matches the variable type, and they're called get followed by the variable name. Pretty straightforward, pretty boring, right? But important, because without these getters, another class would have no way of accessing that information since we made it private by design. So there's my getters. Next up is my setters. Some setters will look very similar to each other. So setters are usually void, and they take in one parameter of the same type as your variable, so in this case string first name, and they just allow you to update the value of your instance data variable. So again, often your setters will be pretty straightforward like this. But sometimes your setters will have some validity checking in them. And what I mean by that is that oftentimes you want to restrict the values that you can give a certain variable. So I've made my student ID an integer, and let's say I know that all of my IDs range between 0 and 10,000. So they're basically up to a 4-digit ID. Let's just say that's the case. I have a kind of a small school that I'm working with, and that's how they want to restrict their student IDs. So if this variable was public, another class would be able to come right in and set this to be a negative number, for example. We wouldn't want to do that. So we make it private so that another class can't directly access it. But if we were to create just kind of your standard setter like this, well, this doesn't solve the problem either, because still another class could come in and pass in a negative number as a parameter, and then I'm still assigning an invalid number to my student ID. So what I can do is I can put a check, a conditional inside my setter to make sure that that value that I'm getting is appropriate. So I can say, okay, well, if student ID is greater than or equal to 0 and student ID is less than or equal to 9999, for example, then I'm going to go ahead and update that value. And if it's not, I'm just not going to do anything. So this is the real power of keeping instance data variables private, is that you can put restrictions inside the public setter method so that those values can only be updated in ways that you specify. So this will be very helpful often whenever you have numeric instance data variables or other variables that you want to, again, restrict the value that they can be given. So these are kind of my basic building blocks so far. I've got my instance data variables, constructor, getter, and setter. So let's just take a break and flip over here to a tester program that I have, which has a main method where I've created some student objects. So I've created 3 student objects with a first name, last name, and student ID. I've got Sally Studier, Pete Procrastinator, and Alan Asks a Lot. These are 3 of my students. And then I'm just invoking a setter method on Alan. He actually asks a ton, so I'm just kind of updating his last name. And I'm going to attempt to update his student ID, but I have an invalid value here, so that really shouldn't make a change to that information. And then I'm just going to print out my 3 objects. So when I run this program, I don't get any errors, which is good, but this is what prints out. I get this kind of unhelpful student at blah, blah, blah. What this is it's a representation of the place in memory where this student object lives. This isn't a very helpful text representation of my student. Typically, when I print out an object, I want to kind of know from a human-friendly standpoint what's in that object. So the last piece that you should always include when you're writing your own classes is a toString method. And the toString method allows you to define a text representation of your object. Now, the toString method always has this header, public string toString. This method is overriding the toString method that exists in the object class. So the object version of toString prints this. It returns this string, this memory representation. That's not what we want. So we want to override that method and provide our own text representation. Whenever we override a method, I'm going to strongly suggest that you use the @override annotation. What that does is it just puts a compile time check to make sure you've got the appropriate header. So when we override a method, the method header always has to be exactly the same as it was in the parent class. And if I've made a mistake in here, let me just put in a return statement so we can get rid of that compiler error. If I'd had a mistake in my method header, let's say I'd put an extra R in there, with the override here, I will know that. It will tell me, it gives me a compiler error saying, ooh, there's something wrong here with your overridden method. If I didn't have that annotation in there, I could just go ahead with that error. And this might be a really tricky thing to track down in testing of why my toString method isn't working correctly. So I'm going to encourage you whenever you override a method to use the override annotation, which is just @O override, because it puts that compile time check on things. If you have questions about this, or if this is the first time you're seeing this annotation, please post those to the discussion board and we can talk a little bit more about it. Okay, so inside my toString method, I get to decide what I want my text representation of my objects to be. 2 different people writing a class will choose 2 different things perhaps, but I am going to say that my text representation is going to be the student's last name, followed by a comma space, followed by their first name, followed by their ID in parentheses. Again, you might choose a different text representation, and it'll all depend on the purpose of your class and what it's going to be used for. So these are the basic building blocks you should have in every class you write. Instance data variables, constructors, getters and setters, and a toString. Now there's going to be more things you should add to your class, including an equals method, which we're going to look at next. But at the very bottom line, this is what you should have. And let's now, for the last thing here, let's look at our new toString method. So now when I run my main method, I get my nice human-friendly printout of my text representation of these three objects with the last name, comma, first name, and the ID in parentheses.